All right, good morning, Year 7s. Welcome back. It's Thursday morning. Someone else is in the chat. Don't know who they are, but hello. They say hello, Mister. Well, hello, TVN JIROU dash. All right, Year 7s. I think we'll just get started. It's 8:57. If anyone else joins in, they can just join in and ask a question if they need to. Oops, sorry, I don't want to do that. Let's not make it upside down for you. Okay. So, I believe week 2 is what we're going to do this morning. We're going to focus on week 2. And it is converting between fractions, decimals, and percentage. Now let's have a look. 4i is the activity, and that's pretty much it. It's just exercise 4i. So definitely the fluency questions, definitely the problem-solving questions. Every second question, of course. Don't do every single one. Every second will be fine. And if you'd like, because we have a bit more time this week, we don't have as many questions in week 2, you could have a look at the reasoning and enrichment questions as well. So just remember, when you're doing each question, there are examples there to show you how to do them. So expressing these percentages as fractions or mixed numbers in their simplest form. Can I get a comment in the chat? Could someone even in the YouTube comments describe how you do it? How do you convert 19% to a fraction? All right, looking at the comments. Are we going to be able to do this for science? Yeah, we'll do it for science. Yep. I'll tell you about science after this chat, and I'll email you guys about science as well. But yes, we can do a live stream. All right, so Curtis has got 19 out of 100. Good morning, Gail. Yep, 19 out of 100. Okay, do we have any other takers for 19 out of 100 or anything else? Yeah, that's right. Yep, so Bree's got it as well. Hi, Zach. How's it going, mate? All right, so basically, when you're looking at percentage, anything with a percent sign on the end means that the number here is actually out of 100, right? So 19% means 19 out of 100. And if I write the word percent, it means, well, the cent comes from the word century, right? It means 100. So it's actually per 100. It's out of every 100. So the answer, 19 out of 100. The question then becomes, can we simplify, right? And you'll be asking yourself that question every single time you do it. 19 is a prime number, and it can't be divided into 100, so the answer is just 19 out of 100. Yeah, Bree's got just put out of 100 and it works. Yeah, you're pretty much spot on there, Bree. You just put out of 100. So we'll go to something a little bit more complicated. Let's go 72. Yeah, let's go 72%, right? So as we all agree, we just write 72 out of 100, right? But then we've got something else going on, and it's this idea that we can simplify. So again, we can use the strategy of halving both of these numbers and continuing to halve and then dividing by 3 and 4. But I reckon I can just ask you this question. What's the highest number, we call it the highest common factor, that 72 and 100 can both be divided by? So I'm thinking maybe 24, no, 25, no, 18, no. It might be Might be 4. I'm thinking 4 might be the highest number that both of these can be divided by. Well, let's try it. So 72 divided by 4. So half of 72 is 36. Half of 36 is 18, so that's divided by 4. And 100 divided by 4 is 25. Yeah, so it's 18 out of 25. Can't simplify that anymore. So that's that one. And we will look at C, because this is going to give us a different answer as well. So let's go ahead and do it. Again, we still do 160 out of 100. But we can still simplify this, can't we? We could easily divide both sides by 10, right? And if you divide both sides by 10, you cancel the zeros out on the end of the numbers. So now you have 16 over 10. And then we can divide both sides by 2, which would give 8 over 5. Whoops. Okay, so now we have our 8 over 5. We can leave it at that, or, as the question states, you could leave it in a mixed number as well. So let's change 8 over 5 to a mixed number. So inside of 8 fifths, if you imagine 8 fifths, there are 5 of those fifths, right, which is 1 whole, 5 fifths, and then there'd be 3 fifths left over. So that's how we express it as a mixed fraction. So yeah, 8 over 5 is correct. Yep, 1 3 fifths. We got it, Gail. Nice work. Okay. Similar scenarios with question 2. It's pretty much the same thing. I'd now be happy. Here we go. Let's do question 4. Question 4 is actually the opposite. We're going from fraction to percentage. So, where we divided by 100 previously, could anyone, again, in the chat explain how we do all of these questions in question 4? How do you go from a fraction to a percentage? Let's see if anyone can respond. Just the number in the top is the percentage. Bree, you're very close. Whatever is the top, you put as a percent. Yeah, okay. Both of you are on the right track there. Divide by 100. Okay. You guys are all pretty close. Gail, you're pretty close. Basically, if your number on the bottom is 100, then, as Bree and Zach have already mentioned, the answer, you just read the top number. So it's 8%. Right? That doesn't always work, and we'll get to examples very soon, why it doesn't work all the time. So 15 out of 100 for part B, it would just be 15% because it's out of 100. Here, let's go to E. E's a bit different. So the whole point of E is to show you that there are fractions where the bottom number isn't actually 100. So what we do is we use either multiplying tricks or dividing tricks to turn this number into 100. The easiest way for me to turn this number into 100 is to multiply that number by 5. And so if I multiply it by 5, whatever I do to the bottom, I've got to do to the top. And so that answer will give me, so like that, it'll be 35 out of 100. So these two fractions, 7/20ths and 35/100ths, they're the same. It's just that this fraction just is a bigger fraction. Same value though. And then you just read the top number because now we have a bottom number of 100. So it's just 35%. So let's do another one of those. let's go to, let's do K. I like K. So again, it's 20/5, but here we've got 5 on the bottom. We need to turn this number into 100. So we're going to multiply this by 20, because 5 times 20 makes 100. But whatever you do to the bottom, you do to the top, and you get, big number here, 20 times 20, well, that's 400 over 100, which equals 400%. Why is it 400%? Well, the bottom number is 100, so you just read the top number and just say percent on the end. Okay. Happy for anyone else to write in the chat, what questions are you stuck on? Would you like me to do anything? Maybe a problem-solving question, maybe one that I've skipped. Please let me know if there's anything you want me to go through. I'm getting lots of question 8s. 13. I'm seeing 8 and 13. Happy to do both of those. That's fine. Yep. All right. 8 and 13. Cool. I'll just do 8 first and then we'll do 13 next. Here we go. Let's go ahead and copy this. Copy. And I'll make a new page. Blow this up a bit. Okay, this is question 8. So, Petrina scores 28 out of 40 on her fractions test. What is her score as a percentage? Oh, I like this one. This is a good one. So, first of all, let's just write 28 out of 40. We need to convert this to a percentage. So, essentially, we need to use either a multiplying trick or a dividing trick to turn this number into 100. Okay? I could multiply this by some... well, if I multiply by 2, I get 80. If I multiply by 3, I get 120. So if I multiply by 2.5, I should get 100. But I'm not sure if I want to multiply by 2.5 right now, because then I'd end up getting a decimal on the top, and I don't want to do that. I wonder if there's an easier way. Well, notice previously I said we can use a multiplying trick or a dividing trick. Well, it turns out we can do multiplying and dividing not at the same time, but in a step-by-step process. So watch me as I do it. My first step will be to divide by 4, and then whatever I do to the bottom, I do to the top. I'll explain in a moment. If I do that, I get 7 over 10. Why did I do that? Why did I go to divide by 4? I divided by 4 because I knew I could then get to 10, which easily multiplies into 100 if you times that by 10. So if you're stuck on a number that can't get to 100 straight away, see if you can turn this number into another number that can then eventually get to 100. Kind of like a 2-step process. Okay, this might not be the only way. In fact, I'm looking at the chat and it looks like, Gail had another way. Gail recommended dividing this by 2, which would make 20, and then timesing by 5, which would make 100. That's perfect, Gail. Really good example there. That also works. I'd accept that as well. But we'll keep going with what I suggested. So now we're timesing by 10. Whatever you do to the bottom, you do to the top, and you get 70 out of 100, which equals 70%. And I like Gail's process so much that I'm going to do his just to prove that it's also correct. So 28 over 40. So if we divide by 2 on both sides instead, so divide by 2, you would get 14 out of 20. And then like Gail said, try multiplying by 5 now, and you get 14 times 5. So I guess this, for me, I think I like the first strategy more because I can multiply 7 by 10 easier than I can 14 by 5. but fairly straightforwardly, 14 times 5, guys, just times by 10 and then halve it. So 14 times 10 is 140, and then halve that, that'll make 70, which will be 70%. Cool. That's question 8. Happy with that? I'm getting a question 5 from Bree. I will go back to question 5, Bree. Just remind me if I forget. But we're now we're gonna do question 13. Yeah, Curtis is thinking. That's fine. Keep thinking, Curtis. If you want to ask me a question, please just put it in there. But I'm going to go now to question 13. All right. Oh, wow. The enrichment. Okay. Well, I haven't personally done this one, so we'll do it all together. Take a screenshot. Copy. Oops. And I'll make another one here. Oh, wow. Conduct research on a major lottery competition, if possible. Find out on average how many tickets are sold each week. Find out on average how many tickets win a prize each week. Determine the percentage of chance of winning a prize. Oh, wow. Okay, well, I didn't expect to be doing this, but I guess we can give it a shot. So we can go lottery. Whoops. How many tickets sold each week? Lotteries in Australia from Wikipedia. Let's go to the Saturday Lotto. Wow. So it says here, for a first division, the chances are 1 in 8,145,060. That's to win the first division. That's to win 6 numbers. So if they pull 6 numbers out and you get 6 numbers, you've picked the exact 6 numbers that were picked out of the lottery, you get the first division, whatever the prize is. Second division, it's 1 in 678,755. Wow. So how would I write this for part A? So part A, find out on average how many tickets are sold each week. Oh, man, that's a hard one. I don't want to get caught in the weeds here researching this. I think if you guys want to do question 13, I'd be happy for you to do a research project on this. Sounds fantastic. I just don't want to get caught in the weeds doing this. So I will go to question 5. Sorry about that, guys, but I just don't want to get caught up on that one. But it sounds like a good question. I just don't I'd rather prepare for that one and do it in a later video. If you support that, let me know in the chat. So question 5. Yep, question 5. Let's do these. All right. Convert these fractions to percentages by multiplying by 100. Okay. All right. Let's pretend that I'm not here and you're on your own. The strategy for this question is to look at example 27. Okay? So let's look at example 27. Here it is here. I'm going to go ahead and delete all of this. I think I did this in a previous video. Actually, this is a question I think that Zach was referring to previously earlier in the week. So we've got this fraction here, and we're trying to convert it to a percentage. What is 3/8 as a percentage? Well, it says here the strategy is to first multiply by 100. So it looks like they've done this. 3/8, yep, that's the question. And then they've multiplied by 100 over 1. So 100 wholes. That makes sense. And then they start simplifying or cancelling. All right, let's try that. So 1/8. Let's multiply by 100 wholes. Okay. So let's do that. So next step is we rewrite this question. We rewrite it by showing the factors that make up these numbers. So factors are like numbers that multiply to make these numbers. I could do for 8, 4 times 2. I could write 8 times 1. I don't think that's going to be as helpful. Let's do 4 times 2 for 8. And for 100, let's do 4 times 25. You'll see why I do this in a moment. So 1 over 4 times 2 times 4 times 25 over 1. So this is the same as this. The only difference is I've broken 8 into 4 times 2. This is the same as this. The only difference, I've just broken up 100 into 4 and 25, because 4 times 25 makes 100. So I've just broken them up into their factors. Now that I've done that, I can cancel out factors that are the same on the top and bottom, because when you multiply by 4 and then you divide by 4 at the same time, the equivalence is just you're just doing nothing, right? So you can mathematically cancel them out. And so what are we left with? We're left with 25 over 2. So let's write that. Okay. Now let's see if we can go back to our example to see what they do next. Yep, the same strategy as before. They turn their denominator into 100, right? So in this example, when their denominator was 25, they multiplied by 4 to get to 100. The same strategy as before. So let's go ahead and do that. Here we have 25 halves. So this number down the bottom needs to multiply by 50. So times by 50 times by 50. And what do we get? Whew, this is starting to get pretty complicated, isn't it? So it's something out of 100. 25 times 50. That's a big number, isn't it? Let me just review my steps. So first, I multiplied by 100. I cancelled out common factor. I'm left with 25 halves. Okay, and what do I get now? 25 times 50, that's a hard one. So that's 25 times 10, which is 250. Oh, you know what? Not liking this strategy here. Not liking this strategy at all. This is resulting in really large numbers. I'm thinking there might be a better strategy for us, and I've got it for you. Okay, let's do something a little bit more different than this. This is not as nice. Gail, thank you for the answer, 1250. Yes, so we could write that there, but I'm just not happy with this, right? And the reason why is because from here we can get to the answer. When you divide by 100, you move the decimal back 2 places, and so the answer is 12.5%. But this is long. I don't like the textbook strategy. I'm actually going to show you a better way. We're just going to divide 1 by 8. 1 divided by 8, using kind of like long division. Okay? So let's do it. How many 8s go into 1? None. Right? None. So we put a decimal here, and then we put a 0. Yep. So now we go, how many 8s go into 10? Well, 1 does, and 2 will remain. So we put a 0 and put that remainder 2 right there. And now we have 20. How many 8s go into 20? 2. That would make 16, with 4 remaining. Put a 4 on another 0. How many 8s go into 40? 5 exactly. So that's our question done. We're now left with a decimal, and hopefully from your previous exercises, to convert a decimal into a percentage, all you do is multiply by 100. So move the decimal forward 2 positions, and so your answer is 12.5%. For me, that's way easier, it's quicker, and I didn't have to deal with really large numbers. Okay, let's do 1/3. So the reason why we're doing these ones with a different strategy to these ones is because with these ones, it's a little bit harder to turn them into 100 by multiplying and dividing with those real simple strategies. So we're doing it this way instead. So here we go. 1 divided by 3. How many 3s go into 1? Well, 0, right? So put a decimal and make a 0. How many 3s go into 10? 3, because 3 times 3 is 9. So there'd be 1 left over. So put a 1 here. Make a 0. Next, how many 3s go into 10? Oh, we're repeating ourselves. It's 3 with 1 remainder. Can you see how it's going to go on forever and ever? So we just write 0.33, and then we can just do a dot on the top. And that means recurring. So now what we've got is a decimal where we can multiply by 100, and we get 33.3 recurring percent. Okay. I'll throw it back to you guys. What question would you like to do? Yeah, Zach, you can do 33 to 99, but then it's not 100, isn't it? Gail's asking for 12D. Zach, I'm happy to work on that question 13. And I can come back at a later time and have a look at it with you. All right, so Gail, 12D. Let's look at 12D. Oh, yeah, okay. I like it. Write each of the following percentages as fractions. Okay. Let's review quickly how to convert any percentage to a fraction. So if I've got 50%, right? How do you convert that to a fraction? Well, you just write out of 100. 50 out of 100. Yeah? But here we've got something different. We've got 33.33%. So we've got a couple of different strategies here. First of all, it doesn't look like there's an example related to this. See how there's normally like text here saying, example 27, or it's not there. So it's up to us to have a think about it. Strategy 1. Let's see if we can just deal with the 33 for now, right? So if it was just 33%, it would be 33 out of 100, right? And I don't think we can simplify any further than that. We will just leave it as 33 out of 100. But we've got this extra bit on the end. We have a third, right? What does that represent? Well, it's a third out of 100, right? So this here, let me just circle a couple of things. This relates to this arrow. Let's do this part, the 1/3%. Over here, it would be this, 1/3 out of 100. But that looks weird, doesn't it? In maths, we don't normally write things like that. So what we can do is we have a little trick. We can convert 1/3 to a decimal, right? By literally dividing 1 by 3. Yeah? So how many 3's go into 1? Well, none. Put a decimal and put a 0. How many 3's go into 10? 3. And you know from previous examples that this is going to be 0.33 recurring forever, right? And so what we know then is that if we combine what 33 is as a percent, which is this, and what 1/3 is as a percent, which is this, we can combine them together. So the final answer will be, I'll write it in black, 33.33 recurring out of 100. Hope that helps. So basically, all we had to do was convert the third to a decimal. Now, does anyone see a problem? The problem is that we are left here with a decimal. What do you guys think we could do with that? Okay, 7s. Are there any other questions? Mustafa wants question 9. How about we make question 9 the last one, and then we can leave. Take screenshot, copy. All right, question 9. The Heathmont Hornets basketball team have won 14 out of 18 games. They still have 2 games to play. What is the smallest and the largest percentage of games the Hornets could win for the season? Okay, so let's write down what we know. So far they've won 14 out of 18 games won. Let's turn that into a percentage. Ooh, turning 18 into a percentage would be difficult. But I'm not sure if it's impossible. 18 can easily... 14 out of 18. All right. I wonder if you guys could help me with this. How do we turn 18 into 100? Let's get this to a percentage. Okay. I think I know what this question is trying to ask. So this is what their current record is right now. 14 out of 18 wins. But they're asking, what's the smallest and the largest percentage of games the Hornets could win for this season? So if they lose the last 2 games. If they lose the last 2 games, this will be the scenario over here. They'll have still won 14, but it'll be out of 20 matches. That'll be 14 out of 20, because then they've played the next 2 games. Let's go ahead and work that out as a percent. Times by 5 for both sides. And you'd get 70 out of 100, which equals 70%. Oops. But if they lose their last 2 games, it'll be more of that. If they win the last 2 games, it'll be not 14 but 16 out of 20 games won, and then that will make it times by 5 times by 5. That'll be 16 times 5, that should be 80 out of 100, which equals 80%. So that's question 9. Okay. Let me just check something here. Checking comments. All right, guys. That's going to be it for today. Let me just clarify a couple of things. Make sure that you've finished week 2 work for this week for maths, and please send me a picture of that work by the end of tomorrow. For science, please start science tomorrow. I'll upload science work on Style today for you to work on it tomorrow. They will be the new activities for this week for science. Please do science tomorrow morning. All right, the stream for science, the live stream for science, I'll do that early next week. Early next week. It's probably going to be a not Monday. That's a public holiday. So it'll either be a Tuesday or a Wednesday. We will do a science live stream. MathSpace. As soon as we get off this stream, I will add more activities to MathSpace. All right. Year 7s, have a good day. Catch you later.